I'm gonna record now so I can share with other people. Something in the chat. Perfect. We're all set. Okay. All right, I think we're all good. All right, last two. We've got line Y and we have point A. And we've done E, we've done D, and we've done B. So we have to decide which one is C and which one is A. Thoughts? Anyone ready to match one? Kate.
Line Y is line through point F and E.
Awesome. It's labeled Y. We see that, F and E, perfect. Those are the same thing. So that's going to be letter C. 16 is letter C. And then 17 says point A. We know it has to be letter A, but why does that make sense? When in doubt, let's draw it out. I have intersection of AB, which is right here, and line Z is right here. And so they only intersect at one point, little a. We just wrote about the intersection of two planes up here. Let's write about the intersection of two lines. The intersection of two lines will always be what? A point. Just gonna make a little note over here. Oh God, okay. Sorry, by the end of the day, sometimes my handwriting is terrible. The intersection of two lines is a point. Good. All right, thoughts, comments, concerns? Good, everyone good? All right, okay. We're gonna go down to the next part. This is postulates. So postulate is probably a new word. Is that anything anybody's heard yet? Postulates are like theorems. They are statements we assume are true. I call them like, oh, duh theorems. It's like, oh, duh. When you see it, you're like, well, duh, that makes sense. Theorems are statements someone has proven. They put work in, they've shown why it is true. Postulates are just statements we assume are true. Postulates is not a huge word you need to know, just in case anyone is wondering, that's what it means. And there are four we need to know, and you need to know these verbatim. You need to know them word for word and be able to recognize if one word is wrong and one word is not correct. The key is that they all have two of the undefined terms. They have point and plane, or point and line, or line and plane, or point and something. So they will have two of the undefined words in there. Through any 2 points, there's exactly one blank. Through any 2 points, 1 point, 1 point, there's exactly one what? Line. Do you see why I say it's an oh duh theorem? You're like, oh duh, of course it is. Whoa, rocking out. Line. If 2 distinct lines intersect, then they intersect in exactly one what? 2 lines intersect, 1 point. Very good. If 2 distinct planes intersect, then they intersect in exactly one line. Good, we just wrote that down. And let me draw that for you. Some of you might be much better artists than me. It's hard sometimes for me to show something that's a 3D in 2 dimension. I do it like a book. So I'm gonna do like one page like this, one of my planes is like that, and then one's like this. Kind of looks like a book right there. And the point where, or the plane where their intersection is a line. So here's one plane over here. Here's the second one over here. There are a ton of ways to draw it. I just find that the easiest way. Okay. 2 planes always intersect into a line. A cool way to think about it is like the ceiling and the wall. So the ceiling is one plane and the wall is another plane. And that line right between them is the intersection of those 2 planes. Yep, Cooper. Right. So those walls are parallel, so they'll never intersect. Very good. And that's, you're like leading us right into the next couple days, and we're going to talk about that and explore that. The last postulate, through any three non-collinear points, there's exactly one what? All right, team timeout. Vocab word, non-collinear. Let's even break that down one more. What do you think collinear means? What is a co-worker? Someone you work with. What's another co-word we could use? People co-parent, right? And they parent together. Collinear, what do we think that means? They are linear together. They are on the same line. So if I say collinear, I mean points that are on the same line. They're on the line together. Similar to that, what if I said coplanar? What do you think coplanar means, Billy? On the same plane. Very good. Now let's meet up with the word that I told us to team time out at, non-collinear. Cooper? Not on the same line. Very good. So I'm, in this definition, I'm saying 3 points that are not on the same line. And then non-coplanar is the exact same thing, not on the same plane. Oop. Non-coplanar. Everybody with me? Good. All right, so non-coplanar lines, oh no, sorry, through any 3 non-collinear points, that means that there are 3 points that are not in the same line. So 3 collinear points would be like 1, 2, 3. I could draw a line between those 3. Non-collinear points are as if I just made that last one like go up here. Yes, I could connect all 3, but is that a straight line? Nope, that's a curve. We can't do that. So those 3 points define a plane. Only one. One unique plane defined by these. Now we could do a plane, or we could do 3 non-collinear points on what you would consider not the same plane. I could have 2 up here on my desk, and then 1 down here on the floor. I could put a plane from these 2 points on my desk through the floor, because it's just 3 non-collinear points. It can hit those 2 up here and then this one down here and still be a plane. It's a lot harder to think about because I can't physically shove a plane there for you, but we could make one if we wanted to. Another one to think about like is the door. If I have 2 points on the wall and then 1 point on the door, right now they're all on the same plane. I can take the door out and I can take a point that's on the door and still connect it with the 2 points that are on the wall somewhere. It might be a plane like this. It might be a flat plane. It might be a plane at like an angle. That makes sense? It's hard to think about, so I'm trying to get us to push outside of what we normally think. We want to think, oh, desk is a plane, floor is a plane, but I want us to think about planes in that 3D space. So we'll explore more of it. Another way is like a tissue box. If I were to like cut through the tissue box like here, if I could physically cut through and go, this could be a plane from here, from this corner up to those corners, right through. Does that make sense? Okay. All right. Good, bad, how we feeling? All right, let's keep moving. The next part says write P if the statement is a postulate, write U if it is an undefined term. So let's decide. Is it a postulate? Hint, we just learned 4 postulates. They will be exactly those 4 on the next slide. If it's not exactly that on the next page, it's not a postulate, it's an undefined term. All right, try that by yourself or with your neighbor. Let's go. All right, take another minute. Bring it back. All right, number one, P or U. A point indicates a location that has no size. Who votes postulate? Who votes undefined? Good, undefined. It's nothing like any of the ones we just learned. It's just describing what a point is. Number two, or number 20, I guess. Through any 2 points, there's exactly one line. Who votes postulate? Who votes undefined? Who's not voting? Michael? Postulate or undefined? Number 20. Oh, you gotta know. I'm counting on you, bud. Let's read it. Through any 2 points, there's exactly one line. Is that like the 4 statements we just talked about? Through any 2 points, there's exactly one line. Is that one of those up there? Postulate. Awesome. Great job. Another kind of key thing is that the postulates always will have 2 undefined terms. So like this one has points and line. That's another thing. Undefined will only have one of them. It will be talking about just a point or just a plane or something like that. All right, 21. Postulate or undefined? Undefined. Great job, guys. That one just has 1. 22. Postulate or undefined? Postulate. Wow, we were strong on that one. Love it. Postulate's correct. What about the next one? Postulate. What about the last one? Postulate. Those 4 are verbatim, the exact same as what we just looked at up there. That's what I want. We're not like ad-libbing. We're not making this up. It's the exact same thing always. So if you can know the wording for this, you will be good. All right. Keep moving. Problem number 2. It says EF and FE form a line. Are they opposite rays? Let's draw them. FE, EF. I'm going to put E, and then I'll put F. I'm going to do it in a highlighter because I think it shows up better on the board for you. EF looks like that. Next one is FE. FE starts at F, goes this way. Caleb. I'd love for you to answer it. I think you're right. Can you tell me why you think they're not opposite rays? Perfect. They don't have the same endpoint. The first one's endpoint is at E, right here, and the second one's ending point is at F. And one of the definitions of being a opposite ray, they have to have the same ending point. So number 1 says, do they share an endpoint? That's a no. Do they form a line? That's a yes, but that's not enough reason for them to be opposite rays. So they are not opposite rays. They also have a big overlap. Do you see that everything in between E and F is an overlap? That's the problem. It can only be 1 point. It can't be all of those points all together. So I'm going to say not opposite rays because they do not share an endpoint. All right. All right, good so far? Let's keep rolling. The next one says finding the intersection of 2 planes. So we are going to find out which 2 planes intersect at BF. So let's find BF first. BF is right here. Which 2 planes intersect BF? Who's got one of them? Eli? AEF. AEF. So this guy right here. Who's got another one? Not you. Caleb? CGF. Awesome. These guys right here. And I'll put that pink highlight over it again. Perfect. So those yellow planes intersected it. Now, the ways that Eli and Caleb just described those are not the only two ways. You could have thought in your head a different way to name those planes, and you were probably correct. So let's go over that. So first one says circle the points that are on BF or in one of the two planes. So what are any of the letters we could use? A, we can use A. What else could we use? Yep. F, what else? C, E, G. Anything else? No. The only letters we can't use are DH on the opposite side. It's if you think of this tissue box, BF is this side right here, and then DH is this side over here. These guys, Cooper, kind of like you foreshadowed, they're parallel, and so they're never going to touch. And then the two planes right here that touch BF are never going to touch DH. So awesome. So we can use any letter except for DH. 31 says circle another name for plane BFG. So what else could we call BFG from that list up there? BCG. Are there more options than BFE and BCG? Not on the list, right? Could you think of others off the top of your head, though, that aren't on that list? Okay, then it says underline another name for BFE. What's another name for BFE on my list? BFE. Eli? ABF. Very good. Okay. And so it now says name the two planes that intersect BF. You can name them a bunch of different things. Someone I haven't talked to, can you name one of them? Who have I not talked to? I've talked to you, Cooper. Who else have I not talked to? Who have I not talked to? Oh, now we're getting shy. Talk to your neighbor, talk about what you're going to name them, and then I want to talk to someone I haven't talked to. Check your answer with somebody. All right, come back. Who's going to help me? Who's going to help me? No, is it too early to expect this day too? Okay, Cooper, help me out. GCF. Everyone agree with that? And what's the second one? BCF. We agree with that one too? Are those the only correct answers? Nope. Who had a different answer than that? 1, 2, 3, 4, 5, 6. Awesome. Good. So when we come in tomorrow, we're going to go over our homework, and there's going to be a lot like this where I maybe have BCF and you may have something different on your page. Does not necessarily mean you're wrong. So we'll look at. Sure, Jesus. I did not mean to throw that. You broke the little tip off. That's okay. I have more tips. I don't know what I was saying, but you could have different letters. They mean the same thing. So, okay, let's keep moving. While I find a tip, why don't you guys draw me LM, NL, and MN on your paper. Draw those for me. Oh, draw. They may not be drawn for you, so you may have to kind of sketch through the line. So it says draw with the diagonal. I'm going to highlight because I think that's going to look easier up here once I get my pen going. Does anyone see what shape it makes? Triangle. Mm-hmm. Idiot, why is this happening? I'm sorry, guys. If we can't have tech problems, I guess I have to break my pen and then slow you guys down. All right, catching up. Okay, so I'm going to highlight MN. I'm going to highlight LM and NL. Do you tell me it made a triangle already?
Mm-hmm.
Perfect. Now it says name that plane. What do we want to name it? LMN. Can I use any other 3 letters? Can I write them in a different order? Yep. All right. I sped through that one because I was feeling flustered. Anybody have any questions on that? All right, let's do this last example on here, and then I want to do a couple more. Okay, this says, are AB and BA the same ray? What's the endpoint of AB? A, yep. Why is it A, Eli? Because the arrow's at which letter? B. What about endpoint of BA? What's my endpoint there? B. Now let's draw it. So I'm going to draw A. I'm going to draw B. I'm going to use a highlighter again because I think that that's easiest for you to see. The ray AB goes from A towards B. The ray BA goes from B towards A. Are those the same? No. What's one thing that makes them not the same?
They don't have the same endpoint.
Good, Kamara. They don't have the same endpoint. Anything else that makes them not the same? They go in opposite directions. If they're the same ray, they should go in the same direction. So I'm going to write something along those lines. I'm going to say no. They don't share an endpoint. Someone's watching like a rock movie next door. Do you hear that? Or go in the same direction. All right. All right, I gotta plug on or I'm gonna die. Okay, we are not gonna do math success because that's not a thing. Cooper, question. Yes, I said no, they don't share an endpoint or go in the same direction. What's an axiom? We didn't learn axiom. I think it's kind of like a postulate. I don't really care what an axiom is, so don't worry about that. I don't know why that was on this list because we didn't do that in this lesson. We don't normally take the lesson from the book, but this one was better than one that we could make up with all the different examples. So that's why we use that. Okay, I'm going to put something on Schoology for you that I want you to get on your iPad. It's going to be very similar to your homework, and we're going to go over it out loud so we can practice it before you have to do your homework by yourself on your own. It's going to look like this. So let me go make sure it's not hidden from you on your Schoology. I wonder who gave Coach Fogel a mask. It looks nice.
That was Mr.
Mr.
Bell.
Mel? Oh, wow. I'm kind of jealous. I want one now. We're in C period. If you go to organized by weeks, week 1, Tuesday, it's coming up right now. It's 1-2 practice G classwork. So those of you in class right now can see it, and then those of you who are not, you can go to Schoology right now. I'm sorry, next time I'll upload it before class. That was my fault. Okay, and it looks like this. So I think even if you're Zooming, you can like split screen and see me and your thing at the same time. I'll come back. No. Whatever. Okay, that's as good as we're gonna get. Okay, everyone see it now? Awesome. We're gonna go over as much of this as we can. And then I'll pass out your homework and we'll call it a day. Okay, so before we get started, I want to point out that this line, RN, is not on the plane. RN goes through the plane like this pen is going through my clipboard. So R is up here at like the top of the pen where my finger is, and N is where the line intersects the plane. Normally, if I were to draw this for you, I would do something like this. I put like R out here, so you can see that R is not on the plane. It's kind of a crappy drawing, so that's why I'm pointing that out. So if you want to move R out there and set it there so you don't get confused, R is not on this plane. It's on the line outside of it. All right. Okay, so let's go over these. First one says, name two segments shown in the figure. Who can name one? A segment. Cooper, give me one. Oh, question. A segment is a line with two endpoints. Noah, give me one. AN. Okay, CM. Awesome. Are those the only ones? Nope, there's a lot more, right? Awesome. Okay, number 2 says find or what is the intersection of CM and RN? CN or CM and RN. When in doubt, trace it, draw it. CM, RN. I see you, Nolan. Who else knows? Kamara? Point N, awesome. And you can write point in front of it if it makes you happy. If not, you can just write capital N, call it a day. Okay, name 3 collinear points. 3 points all on the same line. Cooper, give me one set. C, N, M. Awesome. Are there any more? Lydia, you got it? What is it? A, N, X. Awesome, thank you. Yep, 2 sets of collinear points. Doing good so far? Questions, concerns? Nope, okay. What are 2 other ways we can name plane V? So we see the V down here in the corner. Since it does not have any points, it doesn't count as a point, it's just a name for my plane. Instead of naming it plane V, we can pick 3 non-collinear points. Who wants to help me out? AMX. Thank you, Abby. AMX. Who else had their hand up? Cooper, you give me another name? ARC. ARC, I'm going to say is no. Reason is R is the off of the plane. I'm going to say that ARC is a plane. It's not plane V, though. Okay? So since R is up here, the other 2 are on the plane, so that doesn't count. Jane, you got one for me?
AXC.
AXC is good. And then there's several more that we can do. Those are some good options for right now, though. What else? Next one. Are points R, N, M, and X coplanar? Why not? R is not on that plane. What if I had written A instead of R? Would that all be coplanar? They're all on the same plane. What about RCM? Can I make a plane with them? What's my only rule for making a plane? 3 non-collinear points, right? Are R, C, and M collinear? We can still make a plane, though. What if I had, I'll do that. If I had 2 points on my desk at either end of the clipboard, and then 1 point at the top of the clipboard, They're not all on the desk plane, but are they all on their own plane? The clipboard counts as a plane, right? So I can take a point up here off the plane and still put it in with those other 2 points. It just takes any 3 non-collinear points. So again, I can put the 2 on my desk and 1 in the air, and it can be 1 plane right here. So I'm going to say yes for that one. That's a tricky one that's going to take us a little bit of effort. We're going to have to keep reminding ourselves about that one. All right, name 2 rays shown in the figure. It counts as a ray. Sorry, again. And X. What else counts as a ray? NC. Good. There's a bunch on there we could write. Name a pair of opposite rays with the endpoint N. Are NX and NC opposite rays? Did the example we used last, could we use that here? They go in opposite directions? They have the same endpoint, so we're so close, but not quite. What would make an opposite ray with NC? What would make the opposite ray with that? And what? M. Good. It's like alphabet soup in this class for the first couple weeks, guys. So I may like over enunciate because it's so hard sometimes to tell between an N and an M, and then we got masks on our face. So I'm going to do my best. NM. And then how many lines do we see in this drawing? A lot? I think we can count them. 3. 1, 2, 3. Yeah. The thing about lines, since they go on and on in both directions, we can count those up. Segments and rays, there's a lot more than that in here. All right, questions, concerns on that first half? The next part is sometimes, always, never, and I really want to go over this. This really gets in kids' brains sometimes. We get really bent out of shape and like confused, and we just really have to think through it, draw it out, think through all the options. So I don't want us to get too stressed out about it yet. So we're going to do some now together. GH and HG are the same ray. Eli, you say no? We just drew that, right? We drew it in different letters. G, H, and then H, G are not the same. They go opposite directions, but are they opposite rays? They don't share an endpoint, so no. Since there is no way that I could draw them to be the same, I'm going to write never. If there was a way I could prove that it could work sometimes and could not work sometimes, that would be sometimes. And if I can prove yes, it's true, then we'll say always. JM and JL are opposite rays. Sometimes. We could draw them to be opposite rays, right? I could say this is JM. I could say this is JL. Ooh, pretend that's a nicer line than it is. Those are opposite rays. But I also could have drawn JL to be this. Ooh, come back. And are those opposite rays? No. Since I can do both of them, though, it's a sometimes. 3 non-collinear points are contained in only one plane. 3 non-collinear points are contained in only one plane. 3 non-collinear points are contained in only one. That's kind of worded funny. I would say 3 non-collinear points define only one plane. Would that make a little bit more sense? That's always. Are contained, I would maybe say are contained in uniquely one plane. It's kind of a weird writing. I'm trying to get at a postulate. Postulates are always true. If it's not a postulate, it's probably not always, because we can probably think of a way that it's not. Always are really hard to find, so kind of think twice before you write an always, because there's a lot of times that could not be the case. Yeah.
So can you like draw the 3? Like I'm kind of confused on the number.
let's see. If I drew three points on the board, the only plane they can be on is this board plane, right? These 3 points can't be on the floor based where they are at, right? They can't be on the ceiling. If I drew a point down here, I could make a plane with these 3 points, but that wouldn't be the board, would it? It wouldn't be the floor, would it? So through 3 non-collinear points, there's only one plane. Only one plane we get. It's a hard concept and we're gonna keep going. When we do 3, I was not gonna talk about this today. Well, if I could draw a line, that'd be cool. If we have 3 linear points, they do make multiple planes. They could be the board, they could be this plane right here, they could be this plane right here. I could do that forever and forever. So 3 collinear points make up an infinite amount of planes, but 3 non-collinear only make up 1. That's a good question. Okay, if 3 points are coplanar, then they are collinear.
As we come to the end of the day, let us pause for prayer. Lord, I surrender myself to you.
We'll look at those 2 tomorrow.
In the name of the Father,